So let's study the composition of functions, and we'll do that with the following example. Given f of x is equal to x divided by x plus 3, and g of x is 5x minus 3, let's find the two functions, g composed of f and f composed of f, and the domain of those functions, or I should say their domains. So for the first one, so we're going to be looking at g composed of f of x. So recall that this is equal to g of f of x. And so what we think about is taking x and plugging that into f and getting some output, f of x, and then plugging all of that into g. So it might be helpful to write that idea in the following way. We're taking x and we're plugging x first into the function f, and out comes f of x, right? That's the meaning of f of x. It's the output of the function f when we plugged x into it. And then we're taking f of x and we're plugging all of that into g. So I'm taking f of x and I'm plugging all of that into the function g. And what comes out is g evaluated at f of x. So the reason I wanted to write it like this is I wanted to point something out. Let me change colors here. So f, I'm plugging x into f, right? So f has to be defined at x, right? Because we're plugging x into f. Now for the next one, we're not plugging x into g, we're plugging f of x into g. So g doesn't have to be defined at x, g has to be defined at f of x. So g has to be defined at f of x, and that's something to keep in consideration when we're, or keep in mind rather, when we're considering the domain of these functions. Okay, so for this first one, back here, looking at g of f of x, this is equal to, and so what we do is you first write your composition the way it's defined, and then you replace from the inside out. So I first replace, in this case, f of x with what it's equal to, which is x over x plus 3. So it becomes g of x over x plus 3. And then when I do that, I see that in order for the expression in parentheses to be defined, x cannot be negative 3, because then I'd have 0 in the denominator. So right away, as far as the domain is concerned, I see that x cannot be negative 3. So that's how we deal with the domain, is we consider what happens step by step. And then for the next one, I take all of x over x plus 3 and I plug that into g. So what does g do? It takes the input, it multiplies it by 5 and subtracts 3. So here the input is all of this. So I'm going to take that and multiply it by 5 and subtract 3. So 5 times x over x plus 3. And then I'm going to subtract 3. And that doesn't impose any new restriction on the domain, because all I'm doing is multiplying by 5 and subtracting 3. I can't possibly get nothing will be undefined just from doing that if x over x plus 3 is defined, which it is because it's the output of f. It's a real number. So this is going to be 5x over x plus 3 minus 3 over 1, just algebraically simplifying this. So it's 5x minus 3 times x plus 3, getting a common denominator, x plus 3. And that's going to be 5x minus 3x minus 9 over x plus 3. And so this is my answer. It's going to be 2x minus 9 over x plus 3. That's my function. That is g composed of f of x. And we want to also state the domain. So the domain is going to be all real numbers except for negative 3. So we write negative infinity to negative 3 union negative 3 to infinity. This would be our answer. Okay, now let's do the second problem, which is f composed of f. This is a little trickier. So same idea though. F composed of f. By definition, it's f of x. Okay, so what you first do is you replace the inner function, which is f of x once again, and f of x is x divided by x plus 3. So it's f of x over x plus 3. And let me write f over here just so we, for easy reference, f of x is x over x plus 3. Okay, so now what we're doing is we're taking x over x plus 3. Oh, once again, I should state the domain, right? That once again, x cannot be negative 3 because that would cause the expression in parentheses to be undefined. Now what we're doing is we're taking x over x plus 3 and we're plugging that into f. So f is this quantity over, or this expression over here, this function over here. So what we're doing is instead of plugging in x, we're plugging in x over x plus 3. So I'm going to plug in x. Let me do it in red here. So right here, I'm going to plug in an x over x plus 3. And right there, I'm going to plug in an x over x plus 3. Right? Because I'm plugging x over x plus 3. I'm plugging that into f. So this becomes x over x plus 3. Right? That's the top part right there. And then x over x plus 3 plus 3. X over x plus 3 plus 3. And now we have to be careful with the domain. And the reason is because we've already said that x cannot be negative 3, but notice what happened. Now we have this expression in the denominator, and we have to make sure that's not equal to 0. So that's what we have to do. We have to make sure that that expression in the denominator is not 0. So let's do that off to the side right now. So we require that x over x plus 3 plus 3. Let's first set it equal to 0 and then exclude that value, right? Because we don't want it to be 0. So let's find out where it is 0 and then exclude that number. So I'm doing that over here. So that would occur when x over x plus 3 is equal to negative 3 over 1. So that occurs when x is equal to negative 3x minus 9. So that occurs when 4x is equal to negative 9. And that's when x is equal to negative 9/4. Okay? So when x is negative 9/4, that's true. So we don't want x to be equal to that. So x cannot be negative 9/4. That's an extra restriction on the domain. So scrolling back up for a second, when I did this little chart up here, g had to be defined at f of x. That is, we had to get a value. We had to make sure that f of x made g defined. And so what we noticed here was that when x takes on the value of negative 9/4, it makes f of x an expression at which g is undefined. So x cannot be negative 9/4 because it causes f to be something such that g at that f of x is undefined, right? That's the idea. So so now that we've eliminated that value from the so x cannot be negative 9/4. Now we can simplify that the expression for the function, and we'll do so by multiplying top and bottom by the LCD, which is x plus 3. So this becomes x over x plus 3 times x plus 3 over 1, and in the denominator, x over x plus 3 times x plus 3 over 1. And so in the numerator, it's just x, and in the denominator, I'm going to distribute that x plus 3. So I'm looking at x over x plus 3 times x plus 3 over 1, plus, and then x plus 3 times 3. So plus 3 times x plus 3. So this becomes x divided by x plus 3x plus 9, where I canceled the x plus 3's. So I'm looking at x over, it's going to be x over 4x plus, that writing looked a little sloppy, x over 4x plus 9. Okay, and that is f composed of f of x. And my domain, we said that x cannot be -3 or negative 9/4. And you can write that in interval notation as -infinity to -3 union -3 to -9/4 union -9/4 to infinity. So this would be my answer. The function together with the domain, however you want to write that.